This video covers substructure construction techniques, specifically focusing on dewatering methods used for underground open excavations. First, let us understand what dewatering means. Dewatering is the process of lowering the groundwater level around an excavation by continuously pumping out water. This creates a dry and stable working area for construction. Before selecting a dewatering system, engineers consider several important factors, such as the type of excavation, soil condition, required depth of groundwater lowering, rate of pumping, and the possible effect on nearby buildings and wells. Selecting the correct method not only improves construction quality, but also reduces cost and prevents unnecessary ground settlement. Now let's understand why dewatering is so important. If groundwater is not removed, the excavation may become flooded, making it impossible for workers to carry out excavation, reinforcement, or concreting safely. Dewatering improves the stability of excavation sites, increases the bearing capacity of the soil, and prevents problems such as piping and soil erosion. It also protects nearby buildings from excessive settlement caused by groundwater movement. Simply put, dewatering provides a safe, dry, and stable environment for underground construction activities. There are several methods used to lower the groundwater level, and the selection depends mainly on the excavation depth and soil type. The four common methods are sumps, trenches and pumps, well point system, deep well system, and ejector well system. Each method works differently and is suitable for specific ground conditions. In the following slides, we'll understand how each method works, where it is used, and its advantages and limitations. The simplest dewatering method is the sump, trench, and pump system. In this method, groundwater entering the excavation is guided through small trenches into collection pits called sumps. Pumps continuously remove the collected water from these pits. This method is suitable for shallow excavations in coarse-grained soils, like sand and gravel, where water can flow easily. Its major advantages are low cost, simple installation, and easy maintenance. However, it is not suitable for deep excavations or fine-grained soils because excessive pumping may cause soil erosion and instability. This figure shows how the sump and pump system works. Notice that small trenches are provided at the bottom of the excavation to collect seepage water. The water flows by gravity into the sump, where a pump removes it continuously. Although this method is simple, the sump should always be located away from the foundation area to avoid disturbing the soil beneath the structure. Regular inspection of the pump is also necessary, because pump failure can quickly flood the excavation and interrupt construction work. The next and one of the most widely used dewatering methods is the well point system. In this method, several small diameter well points are installed around the excavation. These well points are connected to a common header pipe, which is attached to a vacuum pump. The pump continuously removes groundwater, lowering the water table around the excavation. This method is suitable for excavations up to 5 to 6 meters deep in sandy and silty soils. It is commonly used for building foundations, pipeline trenches, and utility works because it is economical, easy to install, and provides uniform groundwater lowering. This image shows the single-stage and multi-stage well point systems. A single-stage system is used when the excavation depth is within the suction limit of about 5 to 6 meters. The well points are installed once, and groundwater is lowered to the required level. For deeper excavations, a multi-stage system is adopted. After excavating to the first level, another row of well points is installed at a lower level. This process continues until the desired depth is reached. Although multi-stage systems require additional time and equipment, they are highly effective for deeper excavations. Here we see examples of single-stage well point systems in use, effectively managing the water table for construction. For deeper excavations, a multi-stage well point system may be required to successfully manage groundwater levels. This cross-sectional view helps us understand the working of a well point system. Notice how several well points are placed around the excavation and connected to a common header pipe. When the vacuum pump operates, groundwater flows through the well points into the header pipe and is discharged away from the construction site. As the groundwater level falls, the excavation remains dry and stable, allowing construction to proceed safely. The spacing between well points is carefully designed based on the soil permeability, pumping capacity, and the required depth of groundwater lowering. Before designing a well point system, engineers carefully study several important factors. These include the layout of the excavation, nearby buildings and underground services, soil type, soil permeability, the amount of groundwater to be pumped, the depth of the impervious layer, and the arrangement of different soil layers. These factors help determine the number of well points, their spacing, and the required pump capacity. A well-designed system not only lowers the groundwater effectively, but also minimizes settlement and protects nearby structures from damage. Like every engineering method, the well point system has both advantages and limitations. Its major advantages are rapid installation, simple equipment, low construction cost, and clean pumped water with very little soil. It also reduces the risk of ground settlement compared with open sump pumping. However, it has certain limitations. It is not suitable for large gravel, stiff clay, or very dense soils where well points cannot be installed easily. Another important limitation is that the groundwater can normally be lowered only about 6 meters below the pump level. Beyond this depth, pumping efficiency decreases significantly. Now let's discuss the deep well system, which is used for deep excavations. In this method, large diameter wells are drilled around the excavation, and submersible pumps are installed inside them. These pumps continuously remove groundwater, lowering the water table over a large area. The deep well system has a much higher pumping capacity than the well point system, and is suitable for metro stations, bridge foundations, high-rise building basements, and dam construction. Although installation costs are higher, this method is highly reliable for projects involving deep excavations and large quantities of groundwater. This figure shows the deep well system used for large and deep excavations. Notice that large diameter wells are installed around the excavation, and each well contains a submersible pump. These pumps continuously remove groundwater, lowering the water table to a safe level before excavation begins. Compared to the well point system, deep wells can handle larger quantities of water and work effectively at much greater depths. The ejector well system is mainly used in fine sand, silty soils, and low permeability soils, where ordinary well points cannot remove groundwater efficiently. Instead of using suction, this system sends high-pressure water through a nozzle located at the bottom of the well. The nozzle creates a Venturi effect, producing a localized vacuum that draws groundwater into the well and carries it to the surface. An important advantage of this system is that it can lower the groundwater table to 30 meters or more in a single stage. Although it consumes more energy than other methods, it is highly effective for difficult soil conditions. This illustration details the components of an ejector well system, including the recirculation and settlement tanks, the supply pump, and the network of pipes that connect to the ejector wells located around the excavation site. This table compares the well point system and the ejector well system. The well point system is suitable for shallow excavations, generally up to 5 to 6 meters, and works best in sand and gravel, where water moves easily through the soil. In contrast, the ejector well system is designed for much deeper excavations, reaching depths of 30 meters or more, and performs well in silts, silty sands, and clays. Another difference is energy consumption. The well point system is more energy efficient, while the ejector system requires continuous high-pressure water circulation. Choosing the correct method depends on soil type, excavation depth, groundwater conditions, and project cost. Let us summarize. Dewatering is the process of lowering the groundwater level to create a dry, safe, and stable excavation for underground construction. We discussed 4 important methods: sumps, trenches and pumps, well point system, deep well system, and ejector well system. Each method has its own advantages and is selected based on soil conditions, groundwater level, and depth of excavation. Remember this simple rule. Shallow excavation in permeable soil, right pointing arrow, use the well point system. Deep excavation with high groundwater, right pointing arrow, use the deep well system. Low permeability soil, right pointing arrow, use the ejector well system. Small and shallow excavation, right pointing arrow, use the sump and pump method. Proper dewatering improves construction quality, protects nearby structures, and ensures worker safety. Thank you.